So this is page 3 of the volume by cross-section notes. We are going to find an area, right, like this. And based on the area, you're going to get different kinds of slices. If you give the slices a little bit of thickness, right, these little squares or whatever shape it is, a little bit of thickness, you're going to get volume. And if you add up all of the volume, all of these volumes together, you get the total volume of the shape. So think of like a square. You give it a little bit of thickness, it becomes kind of like a slice of bread. And then you add up all of those slices together, you get the loaf of bread, which is like the volume of your entire shape. Depending on how wide the area is, right, at any given spot will determine how big the square that comes out of it, okay, will be. So let's kind of get started with this next page of notes. We can do things with slices perpendicular to the x-axis. So just to kind of give us some reference here, if your cross section is perpendicular to the x-axis, your integral will be x equals dx, and your equations are y equals, so all the x's are on the other side. If it's perpendicular to the y-axis, if your cross sections are perpendicular to the y-axis, then your integral is y equals dy, and your equations are x equals. Okay, so that's going to be kind of like the main part there. All right, now let's kind of move down. So when we look at this particular problem, okay, so AP kind of style kind of question, not too bad. They gave us a graph, so that's helpful. So we have this equation, this equation. Notice that this equation is the top equation, and this one is the bottom one. It's kind of misleading because they put it here, but you can kind of see it goes up. This one goes down, okay? So this is the top, that's the bottom. All right, y-axis is shown, the region R, and the base for the solid. For the solid, each cross-section perpendicular to the x-axis is a square, okay? So the shapes that we are growing are squares, and the cross-section is going to be perpendicular to the x-axis. So I'm going to draw one slice right here. So usually on my paper, I draw one slice. I'll call it S. Okay, so this to this. S will be top function minus bottom function. And so in this particular case, it'll be e to the negative x squared, parentheses, because there's a lot of negatives going on, so you really want to make sure that you use enough parentheses so you don't get confused if you have to distribute a negative. So for example, you would have to distribute a negative here and to here, okay, which a lot of people forget. Okay, so there's your S. Now that I have S, we want to figure out what does one slice look like. If I can find the area of one slice, turn it into a volume, and add all those volumes together, I'm going to get the volume of this whole shape. So our area is going to be a square. Okay, so it's going to be a square, and the square will look something like this. Okay, it's kind of a side shot, so I know some of you guys are like, it's a rhombus, Mr. Dean. Okay, no, it's just a square from the side, so it's kind of angled. Okay, take an art class. Now, the this part right here, what you want to note, this part right here is the part that's actually touching this region R. So this is S. So red, red, okay? And if I want to find this right here, SS, the area of a square will be S squared, okay? Great. So now I have this. What I want to do is figure out what obviously S squared is. But once I do that, if I can give this square a little bit of thickness, right? And we'll call this dx, like over here, dx. Okay, if we give a little bit of thickness dx, then we get volume. And so then we can actually figure out the volume of this one slice, okay? And then be able to draw or be able to calculate the actual volume of this thing. Okay. All right. Now, so how do we figure out what the area is? Well, the area will be, in this particular case, our S. We already figured out what S was, so we are good to go. Okay, minus 1 minus cosine x. All right. Okay, so now all we need to do now is set up our integral. Let's do that. Our integral will be some x value to some x value, and then this right here will be e to the negative x squared minus 1 minus cosine x. This is brackets. This is squared. So this right here is area S squared. Okay? Now, to give it a little bit of width, okay, we give it a certain amount of width, and multiplying these two together, we get volume. Okay, so we're almost done. We just got to figure out where our limits are. So we know it's going to start at 0. Now over here, you might guess that it's 1. But if I plug 1 into this and I plug 1 into this, they're not going to give me the same answer. Okay, which means that they don't actually meet at 1 because the y values are not the same. So we got to actually figure that guy out. So we want the point of intersection here. Okay, so let's see. Hopefully this will work. Take your calculator, you plug in those two numbers into y, you hit graph. Hopefully this thing will graph. You guys can kind of see it's starting to do its thing. A little bit too small, so I'm going to zoom in, and over here you can kind of see what the units should be. So I can zoom in quite a lot actually. So I'll hit 2, zoom in. I want it around 0, 0. So hopefully you'll start to see that. Okay, you can start to see that this part right here kind of looks like what we have. All right, so then we hit second trace. And when we hit second trace, we're looking for the word intersect. Okay, because that's kind of what we're trying to do here. Find the intersection point. I'm going to move my little blinking thing closer. You're going to hit enter because it'll ask first curve. You hit enter. And then it's going to ask you for the second curve. And you're going to see that it jumps. And so if you have more than 2 graphs going on, you push up and down to cycle through them. But I already did the first curve as y1. I want the other one to be y2, and I want to know where y2 and y1 intersect. So figuring that out, we got 0.9. So 0.9419 4408, comma 0.41178,305. Okay, so we don't actually need this one right here. That's going to be if we were doing it in the cross sections were perpendicular to the y-axis. We just need the x value. So this will be 0.94194408. Now, this right here, the reason why we use so many decimal places is because all the error, any rounding error, will be here, and we have our answer perfect to 3 decimal places, which is what the College Board requires. Okay, so if you type this into your calculator, you will get a final answer of 0.4610635,107. Let's just do that in our calculator really quick. Second quit, get back to the main one, math. Now if you go down, it'll be math 9, right? So you can see it's 9 right here at function integration, so you can just do that. You can push 9 if you want. We're going to go from 0 to 0.941944408. Crap. Okay, well, anyway, there you go. There you have it. That's going to be the actual answer. Okay, sorry about the calculator. I'll try to fix that next time. All right.